Right, hello and welcome to this C4 video on integrating trigonometric functions and keys, and we're going to be going on to something called disguised integration. Now, what I've drawn on the board there is a table. Now, what this table shows is obviously your function of x, your differential, and then your integration of this differential up here, of the function up here. Right. So just before, what I'm going to do is I'm going to tell you a few tips about completing this table. I'll allow you to have a go. Personally, I'd ignore doing tan x and tan of 2x because it's a little bit more complicated. We'll go into that in a minute. But I'll tell you some tips, and then you can have a go at this table yourself. Not because I'm being lazy, but I think it's better to teach it yourself and be able to spot it yourself, obviously, than me just going through it as a table. Obviously, in some instances, it's different, etc. But for this, basically, you should know the differential by now, watching this video. If you don't know how to differentiate sine, cos, and tan, really, should know that, but there's nothing more you can do in terms of the tip I'm going to give you. So the tip is, when you differentiate something, you do the opposite to integrate it. Obviously there's a proper method involved behind the scenes, in terms of like the chain rule and whatnot, but I've mentioned that in a few of my previous videos. But for this video, what I want you to do is do sine, cos, and tan for the differential, and then do the opposite of that for sine and cos. Obviously leave tan out because tan's a little bit more complicated, not necessarily in terms of the function. So if you just remember if you do the differentials of the sine, cos, tan, you can do the opposite of them for your integration of sine and cos. So just let you have a go at that now, and then I'll come back. Hopefully that's enough information. So if you didn't get what I just said, then I'll go through it in a minute anyway. So just give you a second for those of you that feel you can have a go at that now. So we'll see you in a minute. Oops, sorry. Camera out. Right, okay, so hopefully you've managed to have a go. Now this is what I'm going to do. Right, so sine x, that turns to positive cos x. Right, your sine of 2x turns to positive 2 cos 2x. If I get any of these wrong, I'm going to check in a minute, so don't be alarmed. Obviously this didn't happen in the previous video. Cos x, remember, it's the odd one, turns to negative sine x. Cos of 2x turns to negative 2 sine 2x. Tan x turns to sec squared x. And tan of 2x turns to 2 sec squared 2x. Okay, obviously you could prove that with the quotient rule, etc. Now, to do the opposite of these, we're not going to change the function back to sine, because the integral of sine can't be sine. That'd be stupid. So what we do is we do the opposite in terms of the other things. So what we did here is we did the differential of sine and times by the differential of x. So the differential of sine, cos, times by the differential of x, which is 1, is just cos x. Differential of sine, again, cos, differential of 2x, not 1, it's 2. So you do 2 times cos 2x. Do the same for this one, principle. Cos of x, do the differential of cos, which is negative sine, do the differential of x, which is 1. Times them together to get you negative sine x. Do it for cos x, cos 2x, so cos x, differential of that is minus sine x. Differential of 2x is 2, so it's negative 2 sine 2x. Tan x is sec squared x, that's because your tan x is your sine x over your cos x. You do the differential of that, use the quotient rule, and your tan of 2x is 2 sec squared 2x. Okay, so ignoring this last column, what we're going to do is do the opposite. So what we did here is we did positive, so we changed the sign. It's the first thing we do. So give yourself a take if you did that. We're not going to change to cos x because we can't change back to sin x as we said. So it just leaves us with negative cos x. Now there is again a method. We don't times the differential, we divide the differential, but that's just the same as negative cos x over 1, which obviously is just cos x. The integral of cos 2x, sine 2x, is not 2 cos 2x, because remember, we're dividing it, not timesing it. Still says, it changes the sign, as we did before, that hasn't changed, but instead of times it by 2x, we do divide it by 2x. Now you could put times 1 over k, but I'm just going to leave it as that. If that didn't make sense to you, you know, for the people that are in my class, do refer to our C4 class booklet on page 29. Cos of x, changing the sign, positive. Sin x doesn't change, because the differential of x is 1, we times it by 1 here, we divide it by 1, that just leaves us sin x. Do the same here, so the integration of cos 2x is the opposite of differentiating it. So differentiating, we change the cos x to sine, negative sin x, we change it to positive sin x, we change the sign. But we change sin 2x, and not to times it by 2, we're dividing it by 2, so you put over 2. Now for these two, it's a little bit more complicated. So that's assuming, no assumes here, that's probably where you got to. I mean, I don't think that'd be too much to expect. If you got to C4, if you've been, as I said, if you don't get what I did there and how I came about them, I didn't go through it in as much detail as I would have liked or would have normally done, but I don't want to waste too much of your time, coupled with the fact that I'm assuming, as I said again, that you are familiar with them and how we did them. But as I said, if you're not, then please do go back to our YouTube video on that. Okay, so how do we integrate this, the sec squared x? Well, we actually do the ln. I'm not going to go into too much detail because these are given to you in your formula book. So, what is the integration of tan x? Well, it's actually, there's two ways you can do it. You could do ln of sec x plus c. Oh yeah, don't forget the plus c's on these, by the way. I didn't do it because I was just being lazy. It was all plus c. That's plus c as well. Now you could do ln of sec x plus c, and then the ln of sec x, sec 2x, sorry. Sec 2x over 2 plus your c. But another way of doing this, I should have left a bigger space, is you do negative the ln, because you can't really do sec x on your calculator, it's 1 over x. So it's negative cos x over 1 plus c. And the ln of the integration of tan 2x, same sort of thing as we did here when we divided by 2, because we were times it by 2 in the differential. So it's the ln of cos x, or cos 2x, sorry, over 2 plus c. Now, I will admit, these little bits at the bottom are a little bit hard to read, but hopefully, as I said, I've explained them well enough. So the integration, and also, don't worry too much if you don't get these. I will, if time allows me, I will be doing a sort of a proper video when I get round to it. I have to go through the course about how we get to these figures. But for now, all I want you to acknowledge is the opposite of differentiating it. So if you forget these, more of these than these, they're in the back of the formula book. So you don't need to worry about that. But as I said, that's hopefully something that you can find fairly easy to understand. Now we're going to go into something a little bit more complicated. This is called disguised integration. Now the reason this is stupendously hard. Well, it's a lot harder than this, but don't worry. It's it's not come up that much. It's come up once, and it's been worth about 2 marks, so it's not the end of the world. If you don't get it, but I must stress, generally for me, I'm the kind of person that opens their exam paper on the day and finds out they've missed a grade by a mark or half a mark in terms of a UMS of 1. That's how it works out on the day. But as I said, this is quite, so therefore you can consider it to be quite crucial, because some students, or most students, won't get this. So don't feel you are one of them, because when I first looked over this, there was no videos at all on the exam solutions. Need to improve on that. Oh, it's quite convenient. So what I did was I thought, oh, I need to put something in my videos to make it a little bit different, better. I was should have been before, but never mind. So disguised integration. What is it? Well, it's very easy. What we've done is oh my god, I'm so embarrassed. It's so bad. What I did before was I integrated something like cos x with respect to x. And we said, oh yeah, that's simply negative sine x. That's what we did. And if you could put limits there, etc. But what about if we had something a bit more complicated? So, it sort of helps if you remember the fact that the differentiation is the opposite of integration in this context, because we're going to be using differentiation weirdly. So what you might get is you might get something like this. So find the integral of 4 sine cubed x cos x with respect to x. Now integrate that. Now, what would you do? Well, you'd be a bit stuffed if you didn't know what disguised integration was. I could suppose what you'd try and do, what you would think, because we've got 2 products of x there, you'd think, oh, it's the product rule, but we're not differentiating, remember, we're integrating, so you can't use that philosophy. But we can use a philosophy of the differentiation is the opposite of integration, and integration goes one way, whereas differentiation goes the other. So if that is going to be integrated, what it's going to give us, to get to that from whatever we need to find, which is the integration, because it's going the other way, remember, is it's going to be differentiated somehow. Now that obviously is the answer to some dy by dx of something, because we said the integration is the opposite of differentiation. Now if it's the opposite of if differentiation is the opposite of integration, or the other way around, whatever, then this answer here, when we're integrating it, because this isn't the integrated answer, remember, all this is the answer that we have to integrate. It's not the integrated answer, it's the answer that we've been asked to integrate. So it's not integrated yet. So this is the answer to a differentiation equation. Now, if you don't get why, I've tried to explain it, don't worry about it. Just know that you shouldn't be able to think that you can integrate that straight away. Now what we've got is this is the answer to a differentiation problem. Now what differentiation is that equal to? So dy by dx equals 4 sine cubed cos x. Now what does that look like to you? What sort of differentiation, this is the key bit that you need to focus on. What is the key differentiation problem that we've got here? How is that going to help us understand this equation over here? Now, for those of you that don't pick it out straight away, don't worry about it. Just means you won't get 2 marks. What you should click in your head, that we've got 4 times a function, so that should be sine cubed x, to the power, the function of a power, times another function without a power. You should think differentiation. What do we use for differentiation in terms of the functions when it has a power? So sine squared x, how would we differentiate that? Well, what we do is we'd use something called the bracket rule, which is exactly what they've done to get this answer. And remember, we said this answer was, we're going to integrate it, so we've not been given an actual answer. This is not the integration answer, this is a differentiation answer, because we're going the opposite way, remember. So this is a differentiation answer, that's all I've rewritten it as here. So what would we have to differentiate to get this answer? Well, do the opposite of differentiation in your mind. What we did was we increased, when we integrate a power, so as I said, we're going the opposite way. So when we integrate a power, this isn't making sense, don't worry, I'm not explaining it very well. We increase the power, because remember I said integration is the opposite of differentiation. We're trying to get the original equation here to get the answer to this, which is what we want. So what we did is we increased the power. So for differentiation, we reduce the power and then times it by the coefficient of that function, and then times that by the derivative of the function without any powers for the bracket rule. So we're going to increase the power of sine by 1, divide, so that's going to be sine to the 4x, divide it by 4, so that's going to be sine to the 4x, and if we do and then the cos x must be the differential of y, of the function of sine, of what we've got here. Differential of sine is positive cos, which we've got here. So if we wanted to check that this is right, which it is, which is y equals sine to the 4x, then we just simply do the opposite. We do the differentiation of this, and we should end up getting this. Okay? So that's how we work that one out. Now I'm just going to pick a few questions. If you want to note that down or whatever, put some notes next to that, then I'll try and go through. I'm just going to go and check some answers on here. Sorry, one second. I'm just going to check some answers, and then I'll put up some questions and we can do some questions together. Sorry, I'm probably best pause the video so you're not wasting time. Hello and welcome. This is a extension of the C4 video. We just had a bit of a break while I picked some questions. Now, just to recap this, I'm going to put it in just a little thing then. I'm going to put this in more of a diagrammatic form. Diagram, basically. So I'm going to rub all this out. I sort of said it was the opposite, okay? So at the top we've got our original function that we may not be given, so sine to the 4x. So, and then what we've got here is we've got the answer of 4 sine cubed x cos x, and we go backwards and forwards to this answer. Now if we wanted to go to this answer from sine to the 4x, we'd differentiate it, so dy by dx. And if we wanted to go back up, we'd integrate it. So, how does this graph help us? So that's how I think of it. Right, so just make sure you can see that. So how does this help us? Well, if you are asked to integrate this, so 4 sine cubed x cos x, you obviously won't be able to do that, because the only way you could do that is by doing the product rule, because that's 2 x's, but we can't do the product rule, it's differentiation, hence this, and we've already down here. So the only way we can do it is integrate it to get to that. So if we integrate that, then it must equal this according to this diagram, which obviously is true. So that means that integral equals sine to the 4 x. And that's as simple as that. So how do we use, okay, so this can be applied, these can be changed to any scenario. This will be the y value, and then this will be the differentiated value. So what you've got to realise is what this value is a derivative of. And obviously you just simply forget this bit, because that's just the differential of the sine, the original bit, and then you work out your powers in order. So you raise that power and you divide it all by the raised power. Okay, so let's apply this to what I'm going to be going through now is exercise, for those of you that are in my class, page 31 of your C4 class book. I'm going to be going through exercise 8.2. 1a says y equals cos 4x, and it says find the differential of that. So what it's doing for exercise 2.2 is working this out in stages. So it's not just giving us this, which is kind. So that obviously is cos to the 3x, without overthinking there, cos to the 3x times differential of cos x, which is negative sin x. So, yeah, is it? You do sin it. And that gets us our negative 4 cos cubed x sin x. And then for 1b, it asks us to integrate this. So integrate. Sorry. Is that right? Sorry, just be a second. And if we integrate that, we just have that plus c. Right, actually that hasn't gone brilliantly. So that was just a little bit of a 8.2 exercise 1a. Oh my god, my head's didn't go well. But if you get that idea, that's all that matters. You just apply it to that really. As I said, it'll only be worth 2 marks. So if you didn't get this video, don't worry so much about it. Just need to think, what is it a differential of, and then work it out from there. So, as I said, hopefully that's been helpful for you, and we'll see you in the next video. Sorry about the way the camera has gone. I always do this in videos where I think I could have added a little bit more just before I upload it to YouTube. As you can see why it's not quite steady. So for those of you that didn't get the question, it was integrate that for 1b. So basically we found the differential of that, and then we're asked to find the integral of that. So that's why it's a little bit complicated. I didn't explain it very well. So we found the differential of the first bit, which was obviously that bit there. So that there is the integral of that. Okay, but obviously you have to put plus c on the end. That's why it says you find the differential of this, and then hence, that hence bit is the most important. It says, basically it's saying use that answer to find this. So basically what it's saying is that answer is this, the integral of that. So hopefully that's been sort of helpful. If it's not, as I say, don't worry, it's only worth about 2 marks anyway. So just focus on the other areas and try and come back to this one if you get time, but don't focus on it so much. So hopefully that's been helpful, that little extra bit there. Sort of the same as that, but not quite. Hopefully it's been helpful, and we'll see you in the next video.